So today, we are going to solve some problems of integration of rational fractions via partial fraction. And how do we do it? Let's answer this simple problem. X squared, the integration of x squared plus x plus 2 all over x squared minus 1 dx. So the first step in solving this kind of problems is to check if your fraction is a proper fraction or an improper fraction. And how do we do that? We divide via long division. We divide the numerator by the denominator to check if your fraction is improper or proper. Since your exponent is the same, we need to check. We're not sure if it's already proper. So let's divide x squared divided by x squared is 1. 1 times x squared is x squared. 1 times negative 1 will be negative 1. And then changing the signs, it will be negative, this one will be positive. So our remainder is x plus 3. So rewriting this expression, we will arrive with 1 plus x plus 3 all over x squared minus 1 dx. So this first expression is an improper fraction, and now it is already a mixed fraction. If this will be like final design ng fraction mo, pwede mo na siya ngayong i-partial fraction. So that will be the integration of dx plus the integration of x plus 3 all over x squared minus 1 dx. Now, focusing on this expression, okay, we will get the factors of the denominator. So that will be the integration of x plus 3, and the factors of your denominator is x plus 1 times x minus 1. Okay, let's not forget that we have here integration of dx. Okay, and then we will transform now this expression into this partial fraction. So that will be equal to a all over x plus 1. Since yung denominator mo, the factors of your denominator are all linear na siya, ganito yung magiging form mo: a over x plus 1 plus b all over x minus 1. Okay? Now, simplifying, let's focus on this part muna and let's leave it there. So simplifying, we will have there x plus 3 all over x plus 1 times x minus 1. That will be equal to a over x plus 1 plus b all over x minus 1. Multiplying all sides by x squared minus 1, we will arrive with x plus 3 is equal to a times x minus 1 plus b times x plus 1. Okay? And then, to find the values of a and b, we need to get the constants of the values of this x. Since yung highest exponent mo dyan ay x raised to 1, now the value here is, the constant here is 1 is equal to a plus b. And then yung constant dito is 3. It will be equal to negative a plus b. Via systems of linear equation via elimination, adding this to equation, maka-cancel si a, you'll arrive with 2b is equal to 4, b is equal to 2. And then substituting this value to this first equation, we'll have a is equal to 1 minus 2, a is equal to negative 1. Okay? Since we already have the values of a and b, we can substitute it to this equation. So your final equation will be the integration of dx plus the integration of a, which is negative 1 all over x plus 1, plus the integration of 2 all over x minus 1. Okay? The integration of dx is x minus the integration of, I'm sorry, I forgot dx and then here dx. The integration minus the integration of dx over x plus 1 plus 2 times the integration of dx over x minus 1. Let the value for x plus 1, let it be u is equal to x plus 1, and then the derivative of u will be equal to dx. And then in this part, let v be equal to x minus 1, and then the derivative of v is equal to dx2. Substituting these values to the expression will arrive with x minus the integration of du over u plus 2 times the integration of dv over v. We all know that the integration of du over u is equal to ln of u. So x minus ln of u plus 2 ln of v plus c. We need to substitute the values of u and v to the original equation. So x minus ln of x plus 1 plus 2 ln of x minus 1 plus c. Simplifying this answer via properties of ln, that will be x plus ln of x minus 1 squared all over x plus 1 plus c. And this is now your final answer. So our next example is the integration of 4dx over x to the 4th minus 1. So this is another example of integration of rational fractions via partial fraction, and this time we already noticed that our example or our given is already a proper fraction. So we may skip the first step, the long division. We may already skip that and go directly to the second step, which is to get the factors of our denominator. So the factors of our denominator are x plus 1, x minus 1, and then x squared plus 1. I got the factors of our denominator via factoring. To transform this integration of rational fractions into a partial fraction, we will equate that into a all over x plus 1 plus b all over x minus 1 plus, since our last factor is unfactorable, the form must be cx plus d all over x squared plus 1. Whenever we have a factor that is already on its simplest form, the partial fraction form must be cx plus d. And then multiplying both sides by x to the 4th minus 1 will arrive with 4 is equal to a times x squared plus 1 times x minus 1 plus b times x squared plus 1 times x plus 1 plus c x times x squared minus 1 plus d times x squared minus 1. Simplifying this will arrive with 4 is equal to a times x cubed minus x squared plus x minus 1 plus b times x cubed plus x squared plus x minus 1 plus c times x cubed minus x plus d times x squared minus 1. So this is our simplified form. To get now the values of a, b, c, and d, we need to get the constants of the following terms of x. So since we have the highest exponent is 3, should have x cubed, x squared, x to the first, and then x raised to 0. Now the constants of the following variables on the left side of the equation from x cubed to x to the first are all 0. And then the constant of x to the 0, the value of x to the 0 on the left side of the equation is equal to 4. Now getting the constants of the following terms on the right side of the equation will have x cubed a plus b plus c, and then no for d. And then for x squared we'll have negative a plus b plus d. And then for x, a plus b minus c. And then for d, or for the last one, negative a minus b should be plus, this should be plus b, and then minus d. So now let's name this r as equation 1, equation 2, equation 3, and then equation 4. Now to get the values of a, b, c, and d, we will use systems of linear equation, and we will combine equations 1 and 3 and equations 2 and 4. So combining equations 1 and 3, we'll have a plus b plus c is equal to 0 plus a plus b minus c is equal to 0. We can cancel out c and we'll have a plus b is equal to 0, or simply a plus b is equal to 0. So now this is our fifth equation. Now combining equations 2 and 4, we'll arrive with negative a plus b plus d minus a plus b minus d. If we add these two equations, it will be equal to 0, this will be equal to 4. If we add this, we'll arrive with 2 times b minus a is equal to 4, or b minus a is equal to 2. This will be our sixth equation. Now combining our fifth and our sixth equation, a plus b is equal to 0 and negative a plus b is equal to 2. If we add this equation, we can cancel out a, and then 2b is equal to 2, b is equal to 1. Now we have the value of b. We can substitute this to our first equation or to our fifth equation, either of the two. So b is equal to negative a is equal to b, which is 1. So a is equal to negative 1. So we have now the value of a. Now to get the value of c and d, we will just substitute the values of b or a into equations 1 or equations 3, or equations 1 or equation 2. A plus b plus c is equal to 0. C is equal to negative a minus b. C is equal to negative of negative 1 minus 1. So that will be equal to 0. Now, I mean, this is a and b. A and b to equation number 2. That will be negative a plus b plus d is equal to 0. D is equal to a minus b. That will be d is equal to negative 1 minus 1. D is equal to negative 2. So now substituting the values of a, b, c, and d to our working equation, we will arrive with a is negative 1, the integration of negative 1 all over x plus 1 plus the integration of 1 all over x minus 1 plus the integration, since the value of our c is 0, so that will be the integration of d, which is negative 2 all over x squared plus 1, all multiplied by dx. Now we let a be equal to x plus 1, so the derivative of a will be equal to dx, and then we will let b be equal to x minus 1, so the derivative of b will be equal to dx2. So substituting this to our working equation, we'll have the negative integration of dA all over a plus the integration of dB all over b minus 2 times the integration of dx all over x squared plus 1. We all know that the integration of dA over a is ln of a, so that will be negative ln of a plus ln of the integration of dB over b is ln of b minus, if we look at this integration, we know that this is the integration of arctangent. So the formula for this certain integration is negative 2 arctangent of x all over your constant, the square root of your constant, which is equal to 1 plus c. So simplifying the properties of ln, that will be ln of b over a minus 2 arctangent of x plus c. Now substituting the original values of a and b to our answer, so that will be ln of x minus 1 over x plus 1 minus 2 arctangent of x plus c. So now this is our final answer.